Okay, so we are following Balaji publication book by Prabhat Kumar. Okay, so we are going to solve the first question. So this question came in AIPMT prelims 2011. Which one of the following statement for the order of a reaction is incorrect? So you have to identify the incorrect statement. Order can be determined only experimentally. Order is not influenced by stoichiometric coefficient of the reactants. Order of the reaction is sum of power to the concentration terms of reactants to express the rate of reaction. These all three statements are correct. Now let us read the fourth one. Order of reaction is always whole number. We know that order can be negative, can be in fraction also, so it cannot be a whole number. So option D is wrong. So answer will be option D. Next question. For the reaction N2 plus O2 reversible to NO, the equilibrium constant is K1. The equilibrium constant is K2 for the reaction this. What is the K for this reaction? This question came in AIPMT prelims 2011. These are the four options. This is a numerical, so we have to write the equations that are given. So I'm writing the equations. N2 plus O2 reversible to NO, then 2NO revert to NO plus O2 reversible to NO2. These are given, and for this equation the equilibrium constant is K1, and the second equation the equilibrium constant is K2. Okay, now the reaction that is given for this reaction NO2 plus, not plus, reversible half N2 plus O2. This reaction, for this reaction we have to identify the value of K. So we are now going to use the first two equations to find the value for K for this equation. So for K1, let us write K1 will be concentration of product to the power the coefficient divided by concentration of reactant to the power the coefficient into, here plus is given, in place of this plus symbol we will consider here, you will write into O2 again, the coefficient of O2 is 1, so no need to write anything. Next for K2 will be equal to NO2. For NO2 we write this way, the coefficient is 2, so write 2, then divided by the reactant NO, how many times? 2 times, then O2, how many times? 1 time, no need to write. So these are the K1 and K2 for the given equations. Now we have to find the value of K. So if you carefully observe, if we make it 1, if we make it 2, and if we add these two equations, then what will happen? So very carefully observe, if we add these two equations, then what will happen? This O2 get cancelled, this 2NO get cancelled. Okay, so what will happen? So this side, sorry, this O2 will not get cancelled, this O2, 2O2, it will form 2O2, sorry. So you will have N2 plus 2O2 reversible to NO2, so we'll get this equation. Okay, now this is the equation after adding the two equations. So for this equation, from this equation we will write this way. If we reverse it, we will get, after reversing you will get 2NO2 reversible N2 plus 2O2. Okay, then now we will divide it by 2. If we divide it by 2, you will have this NO2. Okay, so after dividing by 2, then what will happen? NO2 reversible half N2 plus O2. Okay, this is nothing but the given asked equation. This equation they asked to find the value for. Okay, so how we got this equation? So we got this equation by adding the two equation. So we added the two equation. So for this equation the k will be, so k1 into k2. We have added the two equation. Then what happened? We have reversed it. For reversing the value of k will be 1 by k1 k2. Okay, next then what we did, we divided by 2. Since we have divided by 2, so the power will be 1/2, means the power will be half, like this. Or you can also write this way, 1 by k1 k2. So this is the value for k. Next, so this option is correct. Option C is the correct option. Next, we are going to solve the next question. This question. So the rate of the reaction 2N2O5 is given. Can be written in three ways. These three ways. The relationship between K dash and between K and K double dash R. So same, we have to write this equation. So the equation is given 2N2O5 4NO2 plus O2. Okay, now we write the rate will be minus 1 by 2 d dt of N2O5 is equal to, in the product side, plus 1 by 4 d dt of NO2 is equal to plus d dt O2. Now the question, they have given the value for minus dN2O5 dt, which is k N2O5, means minus d dt. They have considered this. So in place of this we will put the value. For this. So we can write k N2O5, then it is 1 by 2 is there, no? So you write 1 by 2 is equal to, then dNO2 dt, they have considered k dash N2O5, so you can write 1 by 4 k dash N2O5 inside bracket. Then the dt of O2, they have considered k double dash N2O5, so you can write k double dash N2O5. Okay, now this N2O5 get cancelled out, so you can write 1 by 2 k is equal to 1 by 4 k dash is equal to k double dash. Now we have to find that relation between k and k dash and k double dash. So between k and k dash we can write therefore k is equal to 2 by 4 k dash, or you can also write this way, you can cancel it, you can write k dash is equal to 2k. So this is one equation, and between k and k double dash, again you write 1 by 2 k is equal to k double dash. So you can write k double dash is equal to 2k double dash. So this is how we can write. So k dash is equal to 2k, and this way you can write. Okay, so you can write k double dash is equal to 1 by 2 k, or k by 2 you can write. So this equation option number B is correct. Next, question number 4. So question number 4 is, in a zero order reaction, for every 10-degree rise in temperature, the rate is doubled. If the temperature is increased from 10 degrees Celsius to 100 degrees Celsius, the rate of reaction will become. So this question is purely a numerical with this formula. this formula will be used here. So we have a formula, rate at 100 degrees Celsius divided by rate at 10 degrees Celsius is equal to 2 to the power 100 minus 10 divided by the initial temperature, that is 10. So you can write this way, 2, then it is 90 by 10, that is 2 9 to the power 9. 2 to the power 9 is 512. So this is how it is solved. So option B is correct.